Hello, it's Rafael Gutierrez. Welcome to our channel. Today I'm going to talk about bow and how pretty much energy transfers from one area to another. Now, a lot of times people mistakenly think energy as force, but force is something slightly different. It is important for the transfer of energy, but it's actually forces tends to be more important in causing movement of one object to another. Uh, if we're transferring energy, a lot of times we don't necessarily want to uh, get any movement. What we want is we want the amount of damage. Now, if you think about this, force is equal to mass times acceleration. Now, I'm not going to use the international units. I'm not going to use the units, but I'm just going to show you how something works. Let's say you have something that weighs 1,000 pounds, and it's moving at 1 mile per hour. That has the same force as something that weighs 1 pound moving 1,000 miles per hour. Now, if you're asked which one would you rather get hit with, well, you think about moving 1 mile per hour, that's a slow walk. You get hit with something that weighs 1,000 pounds going 1 mile per hour. What that's going to do is it may stop you, it may move you, but how much damage will that really do to you if you're not standing against a cement wall? Well, something that's 1 pound going 1,000 miles per hour, well, you get the picture. Now, there is other things that people actually forget when they're dealing with damage, and that is surface area. If you think about it, if I get 1 pound and spread it across your entire body, you don't really feel that much pain or anything if it goes across it. If I take that 1 pound and localize it in a square inch, well, now you actually have a lot of force in that square inch, a lot of weight on that square inch, and so it ends up being more damaging. So there are actually a couple of equations that I do need to talk about. Now, before I go on, I will tell you guys that on April 28th in the San Diego Central Library in downtown San Diego at 1:45 is usually where we're going to start. We're going to be doing pretty much a author presentation, and I'm one of the authors, so I figured I'd mention it on my channel, and hopefully some of you who are watching wouldn't mind showing up and seeing what we do. Now, one of the things with the whole idea of the signings, it is a way for me. A lot of the things I do, for instance, the book signings, are technically for me to help support me doing these channels and have a reason to do it. So if you're here, please come by. If you're actually an author yourself, come. I would love to meet you. If there's anything I could do that can help you out, that would be something that I really would enjoy. So just let me know, and we'll see what we can actually do. Now, the thing I was actually going to talk about is the movement of a bow. Now, a lot of times people talk without really understanding basics of science. What I mean by that is most people, when they think of using weapons, they think of it's just basic mass times acceleration. That's force, and it does have something to do with it. But again, remember, mass times acceleration. There's an idea that energy and force has to be conserved. So mass times acceleration always has to be equal to mass times acceleration. And that's actually important with bow. If we take this pin to represent a bow, and we take a look at two different types of sticks. Let's take the red being something like a baseball bat, the red and black together being a bow. What we notice is, as this moves, this part here, the tip here, the edge of the bow will move a lot faster than where the tip of the baseball bat is. What that means is the force, it's the same force, mass times acceleration, but the force is you're actually using some mechanical advantage, and so it's being applied quicker. Same force, it's just being applied quicker. And so what ends up happening is if you're actually using this as a lever, you may be able to move something more easier here than over here, but you'll be able to move this area faster than this area here. In essence, you're actually going from, let's say, 1,000 newtons of force moving 1 mile per hour. Over here, let's say, you'd actually go 1 newton of force moving 1,000 miles per hour here. And so that's actually one of the big things. Now, yes, this is an exaggeration, but it is just meant to show you how that is going to be. With bow, it would probably be the difference between two. So if the force you're generating here is 700, it may be 2 more feet over here. that you would actually end up getting. So you'd actually get 2 times the force. So you'd be somewhere in the if it's 8,000, it would be somewhere in the 16,000. Now, before everyone jumps to those numbers, like I said, this is assuming that the bow and the baseball bat are held and everything's done the same way. I'm actually going to tell you how I did the equations with actually how my friend did the equations, and explain that later. So one of the things that happens is this: when we're actually dealing with how much damage something does, we don't really care too much about force, which seems kind of contra what most people are telling you. What we're really interested in is how much kinetic energy that has. Now, while force is mass times acceleration, and you see it everywhere, plastered everywhere in martial arts circles, the real idea of how much damage something is going to do is usually based on kinetic energy. Now, in kinetic energy, you have mass divided by 2 times velocity squared. So the equation for kinetic energy is the mass, what something weighs, divide that by half, make it half. And then how fast that is moving times how fast that's moving again. So what you see is the velocity becomes a lot more important when we're dealing with damage than the weight. If you think about the weight of a bullet, well, it's really not that much, but how much damage is that going to do if it hits you? That's actually one of the things. Yes, material does tend to be important because of the distortion. And when something distorts, that's energy moving into the place. So that's actually the other thing to think about. Imagine the difference between being pushed, that actually has a lot of force, versus something going in and breaking certain bones may not necessarily have as much force, but it's causing more damage. And so that's one of the big things that we actually looked at. We have to actually look at when we're dealing with force. Now, when I was looking for numbers, what I did in this video is I was really just trying to figure out what type of measuring device I needed. Now, I tend to use Fujifilm's pressure sensor. If you don't believe my results, you can set yourself a premise the way I did, strike and see what your numbers get. What I was trying to do is all I wanted to see is which one I needed, which one of the different ones, and I found that the heavy forces was actually the one that you need for weapons. And this is how I came about it originally. I found that the swing of a baseball bat had somewhere between 700 to 850 pounds of force, pounds of pressure when it actually struck something. Like when it's 7,000 to 8,500 pounds of pressure with the swing. It's a lot. It's actually enough to break bones. Now, what I actually did is I ended up asking a friend of mine who was actually not really a friend, it's more of a colleague who teaches physics. And when I asked him about it, he suggested something, and he actually suggested the lever mechanics. So he said, you need to find out how big a baseball bat is, which we found out was about 40 inches, 42 inches, depending on which. Then you have to determine the length of what you're using as a lever in your bow. Now, I tend to do Yamane-ryu, which tends to move to one end a lot of times. So you tend to use, I would say, probably about 5 feet. So 5 feet divided by, 5 feet times 12, you're talking about 60, roughly 60 inches of the usable length that we're actually using to pull the other side, the side that's beside me, that's not doing the hit. Where we actually would calculate that with weight, but not necessarily with the lever. Now, if we take that, we find that the distance is 20 inches difference. So what we're talking about is, if it's 40, 20-inch difference, we're talking about almost a 50% increase in length. So he actually said you probably won't get the entire use of the stick. He actually said it'd probably go to somewhere between 10,000 to 11,000 pounds of pressure when we actually calculated everything out. So what I did is, when I took that, I did try this out, and what I found is that, well, I'll tell you what I found, and I'll show you the video later. What I found is that he was actually pretty close to dead on. when I actually did the measurement, it was between 10 and 11,000 pounds of pressure. So it was more than the bat. Now, some people are like, no, the bat's going to hit more because it's heavier. Well, it depends on the bat. I actually found out that my bow weighs more than a 42-inch baseball bat. Mine is a ironwood type bow. If you're using oak, even you actually Google the weight of normal baseball bat and the weight of a bow, you'll actually find that your bow is actually heavier than a baseball bat. And so the mass tends to be bigger. But the thing that he said that was interesting is it tends to be this movement here. The velocity increases by so much more that you should be able to get a lot more force with just a hit of a bow. And so that's actually what I did find. Like I said, I will tell you that my numbers came somewhere between 10 and 11,000. I really have seen a lot of people in martial arts jump to attack before they actually do their own work. So I will tell you that if you are one of the people who disagrees, doesn't think that a bow can hit that hard, I would tell you, buy yourself a sheet of Fujifilm. It's about I think it's $50 for a sheet, something the size of a typical sheet of paper. You can cut it, you can do whatever you want, and you can see how hard you really strike. Now the heavy one, it works great for weapons. For straight punches, you can get some data, but it's really hard to read. Usually, if you are going to do those, I usually recommend the light. And I would also tell you, look, it's like if you're teaching martial arts, if you're teaching bow work, if you're teaching weapons, if you're teaching punches, kicks, you do have an obligation to your students to learn what's going on. And especially if you find people who are teaching you something and you disagree with them, well, don't just disagree and not think of it. Do your own research. I actually would challenge anyone who disagrees with this to buy the Fujifilm and see how their strike adds up. I hope you enjoyed watching this. Like I can tell you is I missed a few times. I couldn't get I don't have the accuracy to hit a area, so it did take me a couple swings to get it to hit exactly where I wanted. Usually I had a range about this, pretty much about 3 to 4 inches of range wide, which if you think about it, if I'm swinging a bow at someone and I'm producing that type of pressure, a couple inches one way or another isn't going to make that big of a difference. If you're actually trying to hit a ball, that actually is why you need the accuracy and you need the shape a certain way. So I hope you enjoy this and have a nice day.
To see what a base value is of striking a piece of tape with the bow. So I guess let's try it. A little bit of corner, but let me try one more. So I did get a reading. I'm supposed to wait 3 minutes. Finally hit it. Yeah. Should have actually put a big strip.
It tells you a reading?
Yeah, it actually gives, what happens is it hits.
And it gets the color mark on it?
It gives you a color. And then
you got to go and
go ahead and pause it.